when I make a microphone, I start with a big block of wood, and the first job is to cut off a 4-inch piece. I've already marked it on my saw. And that's that. The next thing I'm going to do is just mark some center lines on this piece so that when I put it in the chuck, it's relatively centered. Otherwise we have a tire out of balance problem, and the whole lathe can literally shake. This is just a parallelogram center, and I'm just going to use it to help me scribe a center line on each side. It's not super critical if the piece of wood is a lot bigger than the finished mic diameter, but sometimes the piece of wood I have is barely bigger, and then it has to be really accurate in the lathe, or it'll end up having a flat side. People generally don't want microphones with flat sides, so I've been told. Okay, so now I have my center lines. And we'll go over to the lathe and chuck it up. Okay, this is called a 4-jaw chuck. There are 3-jaw chucks and 4-jaw chucks. 3-jaw chucks are good for holding round things, and 4-jaw chucks are good for holding square or odd-shaped things. With a 3-jaw chuck, you turn the handle and all of the jaws close at once, but with a 4-jaw chuck, only one jaw moves at a time. So we can really move this thing into position wherever we want it. So I'm just going to kind of start lining up my center marks. I already had the jaws pretty well centered, but I can see this center line, the piece of wood is too far that way. I'll loosen this jaw a little bit, tighten that jaw a little bit, check again, check over here. That's very close. So I'm happy with that. I'm just going to start tightening up. That process alone on a piece of wood that isn't square, for example, or where the chuck was not set to be well, where all the jaws were all centered to begin with. That process can take 15 minutes just to get a piece of wood in the chuck properly. So all we're going to do for now is the very first step in making a wood mic, which is to turn this piece of wood round. This is going to be my dust collector. This is going to be my safety hat. And I need a cutting tool. Now first I'm going to make sure I don't try and cut too much wood. Set some reference points. This is going to make some noise. I'm going to turn on the dust collector, safety hat, yeah, if it gets dusty, hold your breath. I don't know if you can hear me through the mic or not. If you can hear the lathe slow down on that cut. It took all the power of this 1.5 horsepower motor. So at this point I'm going to stop. I'm going to take a measurement and see where I am. This is 2.651 inches. My finish diameter is 2350. That's 300 thousandths, and I have to divide by 2 for the cut depth since we're literally cutting on both sides. I need to cut 150 thousandths more. So I'll do that. Then we're going to do the face. Get rid of a little dust. So that's that. Now we can see what blood wood looks like. A lot of times wood doesn't show off until it's been sanded. I put my helmet. There it is. This helmet, by the way, it's pretty cool. It has a rechargeable battery and it has a fan. And what it does is it blows pressurized air in here. It sucks the air in through a filter, and it's blowing air into the helmet. So that way it's higher pressure in front of my face that keeps all the dust out and it keeps the fog off the safety shield at the same time. Do some 120, some 220, some 320, now you can really see the wood better. It has some pretty grain. It's never very impressive when it's just in a solid cylinder like this. But once it gets the compound curves, it'll start to make those swoopy shapes. All of these straight grain lines will start to make those parabolas on the side of the mic. And you can see how, because it's so hard, it's actually got a really nice, smooth, almost shiny finish just from a little bit of sanding. We won't go any further with this one for now. So let's pick it up with a microphone that's further along in process. This one got turned down. It got the knob separated. It got an aluminum insert pressed into the knob. That's so when I tighten a set screw onto the potentiometer shaft, it won't strip out the threads in the wood. And it's also been bored out to a particular profile here. But still, the shape on the outside is rough. And so I'm going to use a disc here and a mandrel. Once again, have to make it yourself. Put this in the lathe. You'll notice now we have a 3-jaw chuck in the lathe instead of the 4-jaw we had before. There is my Allen wrench. There it is. So now this is kind of all one piece again. And we're going to use this lathe like a wood lathe. A wood lathe doesn't have to have all the stiffness and precision that a metal lathe does. Its job is to spin work. And then we use hand tools like this and a rest called a steady rest. And all I'm going to do is break these angled corners off. This was turned at 0 degrees and then 10 degrees and then 30 degrees to create the basic profile. And I'm just going to smooth it out, and then I'm going to spend some time sanding it to give it its final shape. So now I'm going to start with 80 grit sandpaper. 80. You have to go slower here so we don't generate too much heat. And I have the shape that I want, and the rest is just about smoothing it. So we're going to go from up through the grits of sandpaper. Now I'm using 120. To sand out the 80 grit scratches. Now I'm going to go to 180. 120, 180. We're going to go to 220. $320. And finally, 400. I can find a piece. Little burnishing with my bare hands. Now it's in its final shape, and you can really begin to see the beautiful grain of this piece of burl maple. Okay, so I've just cleaned the lathe up a little bit to get the dust away, and we're going to put the first coat of sealer on this. This is always my favorite part because it brings out the color in the wood. For the first time, you can really see what it's going to look like. I use these foam brushes because I can't stand to clean brushes. So these are disposable. I buy them by the thousands. And then they're only a few pennies a brush. I'm just going to let that spin for a couple of seconds for the glue to tack up so it doesn't run. And then the last step is to loosen the knob so it doesn't get glued to the shell. Don't ask me how I know. And now you can see this is going to be a beautiful microphone. By the way, this is burl maple, and it's very common that it'll have some kind of deep pits and things. So I filled them with a turquoise inlay. That's going to be a surprise for the customer. That's it. Okay, so this is another step. After we've put finish on the mic, the next thing I need to do is create the hole for the connector, and that has to be in a fairly accurate location so that it clears everything else. I've actually mounted a lacer that's pointing down, that's dead center on the axis of my milling machine here, and I've already used the computer to measure back from here a certain distance and to center it from left to right. So I'm going to take that out, turn my light on, I'm going to use a couple of different tools to do this boring. You can never start a drill bit on a on a sloped surface because it wants to tend to walk along the surface. So I'm using a milling cutter first. The other thing I'm going to do is change the milling machine speed to its highest speed by changing these belts. Now I'm going to make that hole a little larger with a drill bit. The size of this hole is also critical because we want the knurled portion of the little screw-on connector to engage the wood so it doesn't want to just spin when I try to tighten the nut. And all that's good enough, except we're not done yet because I need a flat spot for the connector to sit. I'm going to change to a 3/4 inch collet and install a 3/4 inch end mill. This will make a little bit of dust, but not for long. And that's that. Now I'll put a little coat of sealer over this, and the next thing will be to use a chisel to cut a flat spot in here, because when the nut sits down, it's got to sit on a flat spot. Otherwise, it just tries to bend up the wood and it'll crack it. So I want to show you how a microphone grill gets made. This is solid aluminum bar. That's how I buy it. The first thing I would do is chop off a billet like that. Have one here. That goes into the 3-jaw chuck in the lathe. And the first step is to cut out the inside of it so that it fits the microphone. And I don't know if you can see, it's actually got a bevel cut here, an angle, and that's so that it matches the angle that'll be on the front of the grill. If I didn't do that, then when we looked at the slots in the grill, they'd appear to be varying thickness. Right? So once we've turned it around and done the outside of the grill, it looks like this. So this has been shaped and this profile cut, and then it's been sanded and sanded and sanded, again, starting with 80 grit to get off any coarse angles and moving all the way up to wet sanding with 600. Still not shiny, but once it's been wet sanded to 600, it'll polish out really nice. It takes me about 40 minutes to make the grill blank. It takes me another 40 minutes just to sand it out to that stage. And now it's ready to cut the slot pattern in it, because clearly if this is on the front of a microphone, it ain't going to work very well. In order to do this job, the computer has to be at a known starting point. It has to know where it is. And in this case, it's the center of the grill. That's why I put that little red dot there. And that's why I keep these out, because I can't see close anymore. And now I can get in there and just perfectly center it. I'm going to start the spindle to make it easier to visualize. Like that. That, like that. And now I'm going to turn control over to the computer. Now, I'm going to blow compressed air on this to blow the chips away and to keep the bit cool. So that's going to make a little noise. It'll sound like that. And I've loaded a program on the computer here. This is put that in that mode. I tell it is at 0x, 0y, and 0.025 inches in height. Set up my shield. I'll leave this just like that so you can see. And check my work. It really sucks when you do all this work and you ruin a grill because you made some stupid mistake. So now this is under computer control, not me. So it's going down into the metal. This is the yin-yang grill. It starts with 2 holes, then it gets more interesting. So now the whole table is moving, and it's beginning to cut the slot. That's all there is to it. Turn that off. Take that away. So that's that. After that, it gets cleaned up and buffed, and we have a microphone grill.